Hello everybody, today we're just going to do a single video for 2.1. Now pretty much, it's kind of short, we've seen most of this already. First things first, we're going to go over the definition of percentiles. Now, an individual's percentile is the percent of values in a distribution that are less than the individual's data value. If I say this individual falls in the 5th percentile, that means he is only above 5% of all measurements within that data set. If I say individual is at the 80th percentile, he is above 80% of the measurements and is at the 80th percentile. So pretty much, again, we saw this in last year. It's kind of simple. In order to find the actual number, you can just order all the values in ascending order, count how many values are contained from that value and less, and then divide by the total amount. So let's say, for example, I placed 17th out of 30. We just divide that, multiply by 100, and that's going to give you the percentile. Pretty much just like calculating the percent. Only percentile is not the same thing as percent. A percent says, this is 80% of the measurements, this is 20% of the measurements. Percentile says where you fall at compared to everybody else. The 50th percentile would be right there. The 80th percentile would be there. The 5th percentile down here. The 95th percentile up here. So it places you along, it compares you to everybody else and places you at more or less what percent you are compared to everybody else. I hope that was clear enough. I'm sorry. I am going back and forth in the same thing. Now, the next thing we're going to see is cumulative relative frequency graphs. And what is cumulative frequency, relative frequency? We know what relative frequency is. We know what frequency is. Again, frequency is the total number of tallies or counts within a data set. 10,000 males were surveyed. So 10,000 is the frequency, 10,000 measurements. Now, relative frequency, remember, is the percentage. You take that frequency divided by the total amount and or the tally of measurements, and you divide by the total, and it gives you the relative frequency. Now, we're going to see a new thing called cumulative relative frequency. If you go to page 197 on the PDF, you can see right there that we have different age intervals and we also have different frequencies. 2, 7, 13, 12, 7, 3, and 1. And these frequencies all correspond to a particular interval, from 40 to 45, from 40 to 44, 45 to 49, 50, 54, and so on, all the way down to 70 to 74 in the last one. So pretty much, what is this gonna mean? If I'm just taking regular frequency, this would be the frequencies of those measurements. If I'm going to divide, or if I'm going to find relative frequency, I divide that number by the total number of measurements, which would be 45, and I divide 2 by 45. I get the answers here. It's 4.4%. Let me see if I can find a different color that maybe writes a little better. 4.4%. 7 would be 15.6%. 13 would be 28.9%. 26.7%. 15.6%, identical to this other 7. 6.7%. And 1 would be 2.2%. Pretty much half of 2. So pretty straightforward. Now again, this would be frequency and this would be relative frequency, the percentage. Now when we look at cumulative relative frequency, all you're doing is starting from the bottom and then you are adding the frequency and also, if you need the relative frequency, the relative frequency. So for example, the cumulative frequency, straight up cumulative frequency, and the cumulative relative frequency For the cumulative frequency, I would add 2. Right now I have 2. The first one, it's 2. Now I add 7 plus 2 is 9. Now I add 13 and 9. I'm kind of slow right now. It would be 22. Then when I add 22 and 12, it would be 34. Plus 7, 41. Plus 3, 44. Plus 1, 45. This would be the cumulative frequency. It's kind of like the actual frequency, only we start adding the values as the intervals start, going more to the right, or just the next interval includes the previous values. Now, if you're going to do cumulative relative frequency, there are two things you can do. You can just start dividing these values by 45. That's perfectly fine. Or you can just add the percentages as we added the frequencies. So if you add 4.4 and 15 point, the first one is still 4.4, nothing new there, percent. Then if you add 4.4% and 15.6%, that's going to give you 20%. Then if you add 20% plus 28.9, that gives you 48.9%. And for the following ones, we have 75.6%, 91.1%, 97.8%, and 100%. Now, why is this important? Because you might actually do a graph to be able to do quick comparisons on where, the percentiles of a person based on these cumulative relative frequencies. Now, let's see how that works. Now, you write all these numbers down in a table, and then let's work on the graph. Let's work on the graph. So if you go a little bit, if you go to page 199, we have the cumulative relative frequency graph. So the y-axis represents the cumulative relative frequency. So you would go from 0% all the way up to 100%, which includes all the values. And here we have a scale of 10 per unit. So this would be 20, 30, 40, 50, 60, 70, 80, 90, and 100% all the way up here. Again, I am trying my best. Now down here, we have the intervals. So again, I would begin at 40, 45, 50, 55, 60, 65, 70, 75. Note, my intervals, the biggest interval is 70 to 74, but you'll see why I need the 75 there. Now, if we begin, we can easily see that the leftmost dot or data measurement is 40 to 44, which corresponds to 2 people, or as far as cumulative relative frequency goes, 4.4%. So from 40, and you always begin from the smallest measurement in 1 to the smallest measurement for the next interval. So if the intervals are 40 to 44, you would actually go 40 to 45. Okay, and then the next one would be towards the next value, all the way up to, if the first one is 40 to 44, you would end at 45. The next one would end, instead of 49, it would end at 50. The next one, instead of 59, it would end at 60. So you always begin in the smallest value of the following interval. I begin at 40, and instead of going 40 to 44, I begin at 0, and I end at the smallest value of the following interval. 40 to 45, then 45 to 50, and so on. Okay. Now, if you look at the percentages from 40 to 45, I have 4% cumulative relative frequency. So more or less there. Then on the following one, it's 20%. So from 45 to 50, and again, this is important. This is not a relative frequency graph, which you're only looking at the values from 45 to 50. This is a cumulative relative frequency graph. So you're looking at the addition of all the values that come before it. So again, 50 would correspond to 20%. 55 would correspond to more or less 50%. Déjame ver. 40 to 44 is 4. 45 to 50 is 20. 50 to 55 would be 50, more or less here. Then 55 to 60 would be 75.6 or 75%, more or less here. Again, ballparking it. Then I go up to 91%, more or less here. Then 97.8, and then 100%. So you would end up with something like this. Now, why is this graph useful? Because it helps you determine under what percentile, more or less, a person falls under within a particular population. Now, this population is the presidents of the United States. That's why you have the ages from 40 until the oldest one that's ever been elected. You have to be 40 years old in order to become president of the United States. Now, in order to find the percentage or the percentile, it's pretty simple. You just ask yourself a value. For example, under what percentile would a person 53 years old fall, more or less? You go up to 53, which would be more or less here. Then you draw a perfectly vertical line to this value, and then you draw a horizontal value, a horizontal line here. So again, this graph is poorly done, but if it were a proper graph, a person who is 53 years old would fall under maybe the 28th percentile. Okay, let's look at the opposite. A person who is 68 years old. 68, I draw my somewhat vertical line. Now I draw my somewhat horizontal line. Please do yourself a favor and use rulers for this. So I'm guessing 95 percentile maybe. Again, this is a poorly done graph, but that's the point. Also, you can do the opposite. They can tell you, what age would the 43rd percentile fall under? So now you go to the percentiles, 43rd, and now you draw a horizontal line to the graph, and then a vertical line to the age range. So again, poorly done graph. But the 43rd percentile might fall somewhere around 54 years old or so. So this is how you use the cumulative relative frequency graph.